Okay. So previously we were doing this kind of integration. Is that clear? So what I would do is I would place z equals to r e to the power iota theta here. Okay. So instead of e to the power iota z square dz, I would write integration over ab e to the power iota, and z square is r square. I think e to the power iota 2 theta. Is that clear? And dz is r e to the power iota theta, and this r. Is that clear? भरत समझ में आ रहा है यहाँ तक? And this will be integration from 0 to pi by 4 e to the power iota r square. And what is e to the power iota theta? This is, I
So
think,
this we are doing along the arc, no, sir?
this we are doing along the arc. I want to suggest that this, I want to say that this particular integration is 0. So that, I mean, there is some part which is 0, that there will be some remaining part also that we'll see. Let's see what to do about, I mean, I want to know that there would be a part would become 0. That part is AB. Okay, and this part would remain non-zero. So we'll see. So this along AB I'm writing e to the power iota z square ki jagah r square e to the power iota theta. And then you have, instead of dz, I'm writing iota r e to the power iota theta d theta. Is that clear? And I'll get cos theta, and then I'll get plus iota r sine theta. And then I have some iota r, then I have some e raised to power iota theta and d theta. Let us just first get rid of this integral, okay? This looks very complex also. So an obvious thing will be to first encounter this. So what I would do is I'll try to find a modulus of it. I'm trying to find modulus of it. E to the power iota. This will be r cube if I am not wrong. Okay, no, not r. Only this will be 2. This will be 2. Sorry. So e
So
to the power
2
iota.
theta will be there.
All right. E to the power iota 2 theta will give you cos 2 theta plus iota sine 2 theta, and there is an r square. So this is r square cos 2 theta, and then e to the power minus r square sine 2 theta, and then you have iota r e to the power iota theta d theta ka modulus. Is that clear? And this whole modulus would be less than equal to integration 0 to modulus this. So what you will get, this e to the power iota r square cos theta ka mod, then e to the power minus r square sine 2 theta ka mod, and then iota r e to the power iota d theta ka mod, and then you have d theta ka mod. Is that clear? This entire thing would become r, because iota mod is 1, e to the power iota theta is 1, and this entire thing again would become, sorry, I don't have to write it here, I have to write it here. Okay, this entire thing would also become 1. E raised to power iota anything would always be equals to 1. Don't worry about it. Because this is what cos something plus iota sine something, that root over cos square something plus sine square something would obviously give you 1. Integration from 0 to pi by 4. And you have e to the power minus r square sine 2 theta, and then you have d theta. Don't take a modulus, because exponential any day is more positive. Yesterday I told you something called as Jensen's inequality. And from Jensen's inequality, we derive one expression that whenever you have sine, because sine is a concave function. So if I join 2 points, let's say these are the 2 points, and these, if I join these 2 points, okay, if I join these 2 points, what I can get is I can simply say that my sine lies over this line. Okay, so yesterday I told you that sine is a concave function, and the property of concave function is that if I join 2 points and make a chord, your curve always lies above it. So if I just write the equation of line, which I yesterday did, and I got this kind of thing. So sine theta is greater than equal to 2 theta by pi, and that would give me that sine 2 theta is greater than equals to 4 theta upon pi. So hardly it matters. You take 2 theta as some, let's say, phi, and then you have 2 d theta as some d phi. So this will be equals to d phi by 2. So I will write less than equal to r upon 2 integration from 0 to pi by 2 right now, because c2 theta, when you take phi, the integral limits are 0 to pi by 4. So integral limits for phi would be 0 to pi by 2. And you are left with e to the power minus r square. And instead of sine 2, let's say I'm writing sine phi at first, and then you know that sine 2 theta is greater than equal to this. So just multiply minus r square. So minus r square sine 2 theta is less than equals to minus r square 4 theta upon pi. And then you just take e, this kind of thing. And this will be less than equal to e to the power minus 4r square, then pi upon whatever. This theta, and this is pi. So this will be less than equal to r upon 2 integration from 0 to pi by 2. And this will be e की power minus r square. This will be equals to, I think, 4. Then this will be equals to, I know, 5, I think. And then this will be equals to what? Okay. Not even 4. So you can write sine square phi, so you can simply use this kind of thing. So you can simply get 2 phi upon pi. Okay, d phi. Overall, understand that this particular integration, understand my point that this particular integration would come whatever it may be like. I can do it. It's no big deal. I'm just saying that this r square is a constant for right now because you're going to integrate with respect to phi only. Okay, you are going to integrate with respect to phi only. So when you integrate with respect to phi, so what you will get less than equal to r upon 2 e की power minus 2 r square phi pi divided by minus 2 r square upon pi. Okay, so and then you have some limits 0 to pi by 2. Okay, I'm not bothered about these limits. Understand my point that this r square, as r tends to infinity, you have this r gets cancelled. You have some terms in the denominator because e raised to power minus something. Eventually, you will get some e raised to power something here, and this is some expression in r square. As r tends to infinity, this entire thing would become 0. Is that clear? This entire thing would become 0. Okay, exact things you can do it, but overall I'm just trying to tell you that this entire thing would become 0 as r tends to infinite. So overall, as r tends to infinite, the contribution from this arc would go 0. Is that clear? This is what I have shown here. I may be wrong with some sort of constant. I'm not very interested in that, but overall understand that as r tends to infinite, this entire thing would go to 0. Is that clear? कहाँ चले गए सबके सब?
Yes, sir.
Okay, so overall understand that over this, हाँ बोलो.
सर ये जो आपने साइन थीटा ग्रेटर देन 2 थीटा बाय पाई ये सारे लिमिट्स के लिए ट्रू है?
नहीं, 0 to pi by 2.
ओके सर.
0 to pi by 2. Because see, pi by 2 to pi, you can see that sin theta का derivative होता है minus cos theta, and minus cos theta का again, for that also it will be fine. From 0 to pi you can take. 0 to pi your sin theta is a concave function, no issues. ओके, सो मैंने जानबूझ के इसको 0 to pi by 2 बनाया बिकॉज 2 थीटा को तुम t लोगे या फाई लोगे तो ये 0 से pi by 2 हो जाएगा. ओवरऑल ये हमने
हाँ
कल
जी,
बहुत बार किया है. ये हमने बहुत बार किया है. वी हैव डन इट क्वाइट. सो यू विल से कि यार अब इसका करें क्या. सो मैं एक लेमा लिख दूंगा दैट इज कॉल्ड एज जॉर्डन लेमा. So don't worry about it. Overall, understand my point that this entire thing will become 0. Okay, so this entire thing would become 0 means what? Means what? As r tends to infinite, so I'm writing as r tends to infinite, or I can write as mod z tends to infinite. I'm not bothered about this RKC. I'm only bothered about this. I'm only bothered about this. And this entire thing is equals to, don't forget that also, e की power iota z square dz over contour C. Is that clear?
yes sir.
Okay, so I'll write it all over again here. So what I was doing, instead of solving two problems that were given to me, these are called as Fresnel integrals. Okay, I started doing something called as this integration over a contour that I suggested you is an arc inclined at an angle pi by 4. So I found that this is some OA integral. Then there was some integral along AC arc, and then there was an integral along, I think, some. एक मिनट मुझे दोगे? I think this is AB arc or what? क्या है ये? AB है ना? Sorry. AC arc कहाँ जा रहा है? अच्छा, AC is this. Sorry, my mistake. Okay, जो भी है, मतलब understand this is arc. Okay, not AC. This is AB. This is arc AB. So एक arc AB के along, I wrote this C from here, I don't know why, and this along BO. So overall understand that this integration would be equals to AB, and then there will be some BO. Is that clear? And you have to take, I have taken this arc in a way that I have some radius as finite, but overall I have to take infinite. I have to r tends to infinite in order to evaluate these integrals. I have to take r tends to infinite in order to evaluate these integrals. Is that clear? Because we were lacking space, so I have made it here. Okay, so this integral would tend to 0 as r tends to infinite. So forget about it. This integration would become e की power I'm not writing initially. I'll write 0 to r e की power iota x square dx plus integration along BA is BO was what? Along integration along BO was this. So I will rewrite it. I'm going to rewrite it here. So let us first simplify it. So this is from R to 0. So instead of R to 0, write 0 to R and take a negative outside. You have e की power iota r square. What is e की power iota pi by 2? E की power iota pi by 2 is 1. So here it is 1. What is e की power iota pi by 4? That will be equals to iota, sorry, that will be equals to 1 upon root 2 plus iota upon root 2.
That e to power iota pi by 2 is iota, no?
हाँ, e की power iota pi by 2 is, अच्छा, it is iota, sorry, it is iota. It is iota. So e की power iota pi by 2 is, sorry, cos pi by 2 plus iota sin pi. Sorry. So it is equals to iota. So this will become iota. This entire thing will become, will be this. Is that clear? So I'll copy it down there. Okay. I am having lack of space. So understand my point. Is that clear to you? So
Yes, sir.
I'll replace it here somewhere here. Okay. So, sorry, this integration would become, I think, e की power minus r square, and then you have 1 over 2, 1 upon root 2 plus 1 upon root 2 iota, and then you have some dr also. Is that clear? And here you have 0 to r, and you can take minus common. And all of this I'm doing as r tends to infinity. Clear? यहाँ तक कोई दिक्कत?
Yes, sir.
Okay. Understand my point that this particular contour, in this particular contour, your e की power iota z square is completely analytic. What is the problem for this function? There's no problem as such. Okay. E की power iota z square is completely analytic in this contour. So this integration would come out as 0. Okay. Clear? What is the problem that
Yes,
e की
sir.
power iota z square can have? It has no problem in this particular regime. So in this particular closed region. So what I would do is this 0 is equal to integral 0 to infinite. And what is e की power iota x square? This is cos x square plus iota sin x square, and this is equal to 0. So you, what should you do? What should I do? I'll take this integral here. So this will be equals to what? This is equals to integration 0 to infinity e की power minus r square dr, and then there is some constant term. I'm writing it here. This constant term is nothing but 1 over root 2 plus iota upon 2. Is that clear? And this is quite this is an integral that we'll do in gamma function also. But overall, you will know this integral is equals to what? This integral is equal to root over pi upon 2. If you don't know, remember this integral. You'll encounter it quite often. Okay, this
Sir,
will do
small r क्या है?
small r. Okay. Understand my point that when I was moving along BO, any coordinate could be
Okay, r is
represented.
getting changed. Okay, okay,
Here,
okay, okay.
here r is changing. Okay. Here your theta was changing. Here your theta was 0. And how? Are you getting my point? And here I just wrote z equal to x. So
X.
basically it was
Yes, sir. Yes.
equivalent to writing that your r is changing. Is that
Right,
clear?
right, right.
Because this has become quite long question for you. Okay, so indeed what you would get is root over pi upon 2. This is something that you should know, because I believe at MSc level you should be doing all these things. So otherwise I would derive it also in gamma function, but right now just remember this integration. So this will be pi upon 2, and then there will be some root 2 also, plus iota root over pi upon 2 root 2. And this equated by integral 0 to infinity cos x square dx plus iota integral 0 to infinity sin x square dx. And what you've got, eventually this is equal to this is equal to this. And what I've got that integration cos x square dx is nothing but it is equal to root over pi upon 2 root 2, and integral 0 to infinite sin x square dx is nothing but root over pi upon 2. Is that clear to you? So these are very famous integrals. These are very, very famous integrals. So you have to understand, for these integrals, you have to you have to take into consideration a special kind of contour that I made. Is that clear? ऊपर से तो नहीं चला गया ना कुछ भी?
Yes, sir. Clear.
And these integration will find mostly useful when you are doing diffraction phenomena. So their name is, you can search it also. These are called as Fresnel integrals. And I probably do it in optics. Okay, so I would do in optics. So while optics come, I would use them directly. But right now, because I am doing complex analysis, so I've derived them. Okay, so basically, you'll find that in Fresnel diffraction formula. I can write it here. So you'll, especially when you do some. So you will encounter this integration in optics. Okay, is that clear to you?
Yes, sir. And sir, these integrals will be true for within the limits minus infinity to infinity also, no, with the factor of.
Yeah, exactly. No issues. Because even function, it is after all even function only. So you can do 1/2 there. I mean, you'll have to do 1/2 or probably multiply with 2. I don't know exactly. Okay.
Yes, sir.
है ना, so you have to multiply with 2, I think, है ना. If अगर तुम x की जगह minus x square, sorry, minus infinite to infinite करते हो, I think you will have to multiply this entire thing by 2. Is that clear? So I hope it is clear. Now let us move ahead. Let us move ahead and do a few more problems. Okay, so let us do a few more problems from miscellaneous side. Okay, so we were doing some miscellaneous things, and while I was doing those miscellaneous things, I was okay. So let us do some more integrals. So these are like we are coming to the end of this entire syllabus. Okay, so we'll keep doing it. I'm not saying I'll leave you there only. So now, what if I encounter a branch point? And you would understand that you will immediately when I'll do this question, you'll immediately know where you might have seen this thing. So I will ask you after my class gets over. So where have you seen this entire thing, that what I'm doing? Okay. So what if I encounter a branch point inside this contour of integration? Inside the contour of integration. So if I encounter a branch point, again there's a problem. So I will have to evacuate that branch point. So this particular integration, I'll do this. There are loads of integrations. So basically, we are going to do only these integrations only, so that you're able to understand this. Okay. So what I would do is, what I can say that here P lies between 0 and 1. Here P lies between 0 and 1. Understand my point. I told you on the very first day that Z raised to power P, provided P lies between 0 and 1. This is a multi-valued function, isn't it? Depending upon P, this is a multi-valued function, because if P is a rational number, then this will be some multi-valued function. Like for example, if Z is equal to P by Q, this will be Q-valued function. And if P is an irrational number, then it will be an infinite many-valued function. These all things I've told you, and Z equal to 0 is a branch point here. Is a branch point here. So how to go about these problems? Okay, and another point would be equals to x equal to -1. So for example, sorry, if I replace this integration by this, so another singularity would be z equal to -1. Is that clear? ये चीज समझ में आ रही है?
सर -1 पावर में है.
हाँ, पावर p-1. ठीक है जी, बढ़े आगे. दिस विल टेक अ लॉट अमाउंट ऑफ योर टाइम, दैट इज आई एम डूइंग इट थोड़ा सा जल्दी जल्दी. ठीक है, यहाँ तक समझ में आई बात? So instead of I'll write it here. So instead of doing this integration, instead of doing the given integration, I would do this integration. Z की power p-1 upon 1 plus z dz over a contour C, which I'm going to, whose design I'm going to tell you. Okay. So देखो अब डिजाइन में क्या रखना पड़ेगा? डिजाइन में एक चीज करनी पड़ेगी कि now you cannot include your origin inside. ठीक है, तो जैसे अभी तक सेमी सर्कुलर कॉन्टूर ले रहे थे, वैसे तो ले ही नहीं सकते कुछ भी, क्योंकि सेमी सर्कुलर कॉन्टूर लोगे तो -1 भी आ जाएगा और 0 भी आ जाएगा. समझ पा रहे हो मेरी बात? Further, if I'm saying that I have a branch point, then I will have to draw branch cut also. Is that clear? I will have to make a branch cut also. इज दैट क्लियर टू यू? ये चीज समझ में आई कि ऊपर से चलेगी दोनों बातें?
भैया वापस बोलो ना।
देखो, इस इंटीग्रेशन को रिप्लेस करेंगे हम z की पावर p माइनस वन अपॉन वन प्लस जेड डी जेड। ओके, नाउ p लाइज बिटवीन जीरो एंड वन, तो ऑब्वियस सी बात है कि p माइनस वन भी कहाँ लाया करेगा, जीरो से वन के बीच में ही लाया करेगा, मानते हो? p अगर कोई क्वांटिटी है जो जीरो से वन के बीच में, उसको एक घटा दो, ओवरऑल ऊपर जो पावर आएगी वो कैसी आएगी? द पावर वुड बी इन सम फ्रैक्शन ओनली। एंड आई टोल्ड यू दैट z की पावर p इज अ मल्टी वैल्यूड फंक्शन इफ p लाइज बिटवीन जीरो एंड वन। याद करो, बताया हुआ है ब्रांच पॉइंट्स में बताया हुआ है। So I told you this. If it is p upon q, then this is a q valued function. I told you that it is some s where s belongs to
हाँ हाँ
irrational.
हाँ,
Then it is an infinite multi-valued function, and z equal to zero is a branch point. So this, so now the situation demands that I will have to make a contour which does not include zero, one, because zero is a branch point. Okay, and also does not include, मतलब उस कॉन्टूर के अंदर नहीं, कॉन्टूर के अंदर चल सकता है पर कॉन्टूर के ऊपर माइनस वन और जीरो नहीं आना चाहिए। समझ पा रहे हो कहाँ गया वो? भरत कहाँ चले गए? समझ पा रहे हो मेरी बात?
Yes, sir.
Okay, so what I would do is I would make a circular contour, but there's a problem. See, if I'm saying a branch point, then I will have to make a branch cut also. So I will have to give some cut also. So what I would do, it is favorable for me to make a cut here. So what I would do is I would make a cut from here to here. So I'll cut this particular portion, this particular portion. Is that clear? This point I have हटा दिया है इसमें। ये समझ पा रहे हो कि ऊपर से सारी बात नहीं? कैसे मैं करूँ इसको? Okay, so this is a slit construction I have done. So I have created a slit here. Okay, okay. अब क्या किया मैंने? I have created a slit. I will go anti-clock. मैं इसको थोड़ा अलग पेन सुनाता हूँ, so I'll go anti-clockwise. Okay, I'll go anti-clockwise. Then I will enter here. Okay, then I have to evacuate zeros. What I would do, I'll evacuate zero. ओके, तो किया क्या? देखो मेरी बात सुनने की कोशिश करो, मैं तुम्हें वापस समझाता हूँ। देखो होता क्या है, अब देखो यहाँ साफ पता लग रहा है कि z इक्वल टू जीरो जो है वो क्या है? सिंगुलैरिटी। z इक्वल टू जीरो भी सिंगुलैरिटी, z इक्वल टू माइनस वन भी सिंगुलैरिटी। तो मैंने क्या किया, z इक्वल टू वन के आसपास एक छोटा सा सिंगुलर ऐसा बना दिया। छोटा सा क्या बना दिया? वो बना दिया। एंड व्हाट आई हैव डन, आई हैव टेक, अगर मैं इसके अबाउट ही ले लेता, देखो अगर मैं यहाँ पे सेमी सर्कुलर कॉन्टूर लेता, सोचो तो प्रॉब्लम क्या आती? सेमी सर्कुलर कॉन्टूर में एक तो ये सिंगुलैरिटी हो जाती है और एक ये सिंगुलैरिटी हो जाती है, दो सिंगुलैरिटीज हो जाती है। ओके, मैंने क्या किया, z इक्वल टू जीरो को तो हटा ही दिया। ओके, और z इक्वल टू माइनस वन को मैंने क्लोज कॉन्टूर के इनसाइड ले लिया। थोड़ा ध्यान से देखोगे ना तो देखो ये क्लोज ही तो हो रहा है कॉन्टूर। ठीक है, समझ पा रहे हो कि ऊपर से गई बात? समझ पाए नहीं समझ पाए, कहाँ चले गए सारे के सारे? ये स्लिट कंस्ट्रक्शन है, समझ पा रहे हो? ये यहाँ पे स्लिट है, ठीक है। और I'll say that this particular radius is epsilon and epsilon tends to zero। तो मैंने क्या किया, I have enclosed your origin inside a circle of epsilon and epsilon tending to zero। जितना छोटे से छोटा चाहो उतने छोटे से छोटा नहीं सकते। इज दैट क्लियर? कि मैं वापस से बनवाई सब चीजें? देखो मेरी बात सुनने की कोशिश करो। ये रहा तुम्हारा सर्कल, इसमें क्या अच्छे से आएगा नहीं इसलिए, ठीक है। देखो यहां पर था तुम्हारा ओरिजिन, ठीक है, और याद करो ओरिजिन इज योर, ओरिजिन इज योर ब्रांच पॉइंट। सो ब्रांच पॉइंट कैसे लोगे तुम? तो क्या करना पड़ेगा, कॉन्टूर को थोड़ा चेंज करना पड़ेगा, क्योंकि अब सेमी सर्कुलर कॉन्टूर नहीं ले सकते। मैंने क्या किया, मैंने काम किया, मैंने एक छोटा सा सर्कल बना दिया, सही छोटा सा सर्कल। एसबीआई बन गया है तो, जो भी है, एस एसबीआई हो गया ना। ठीक है, तो इसको
यस
ऐसे
सर।
ऐसे देखोगे तो एसबीआई दिखेगा। ठीक है, सो इसका नाम हम रख देते हैं एसबीआई कॉन्टूर। ठीक है, सो ओवरऑल अंडरस्टैंड माय पॉइंट दैट दिस इज योर कॉन्टूर। I have taken now zero out of my zone of consideration. Okay. And this minus one, even if it is there, I will find the residue about it. Don't worry about it. ठीक है, सो अगर है भी तो कोई फर्क नहीं पड़ता मुझे। है तो है, कोई फर्क नहीं पड़ता। बट एक चीज समझो, दिस इज नॉट इन द इन द मतलब path of the integration. So it is inside. So what is the problem with having a it singularity inside? I can find a residue about it. Don't worry about it. Okay. Yes or no? So let us give it a name A. इसको मान लेते हैं B. Then you have this, I think C तो कर्व के लिए हो जाता है, फिर D, पिछली बार कंफ्यूज हो गए थे फिर, तो फिर then you have E, and then you can write it in F, and then you can write G, and you can write H, and so on and so forth. Okay. H and J. और ये जो सर्कल बनाया ना, इट कैन बी एज स्मॉल एज पॉसिबल। भाई हमें जीरो से परेशानी है, हमें बाकी से थोड़ी परेशानी है। सो आई विल टेक अ सर्कल अबाउट जीरो एज स्मॉल एज पॉसिबल। सो दिस रेडियस विल बी एप्सिलॉन, एंड एप्सिलॉन टेंड्स टू जीरो। इज दैट क्लियर? अभी तो कुछ समझ में आया नहीं है? हाँ या ना तो।
हाँ
ओके।
हाँ, ध्यान।
इसके लिए पेन लेके बैठना पड़ेगा, देयर इज नो अदर वे। ठीक है, so
हाँ
इस पूरे काउंटर को मैं बोल देता हूँ लेट्स से सी, क्योंकि वो सी इधर लिखा है, नहीं तो वहां बी सी में सब कंफ्यूजन हो जाता है। तो सी जेड की पावर पी माइनस वन अपॉन वन प्लस जेड डी जेड। इज दैट क्लियर? दिस इंटीग्रेशन वुड बी इक्वल्स टू, थोड़ा सा ध्यान देना पड़ेंगे, दिस इंटीग्रेशन वुड बी इक्वल्स टू व्हाट? एक इंटीग्रेशन हो रहा है अलोंग आई थिंक ए बी, then along B, D, E, F, G, then along G, H, and then along H, J, A. Is that clear? टिक टिक टिक, खत्म। अंडरस्टैंड। हमें करना क्या है, कहां से कहां तक इंटीग्रेशन करना था याद करो, जीरो से इन्फिनिट। देखो यहाँ पे, सो दिस इंटीग्रेशन इज डन इन द लिमिट एप्सिलॉन टेंड्स टू जीरो एंड आर टेंड्स टू इन्फिनिटी। एप्सिलॉन जितना छोटे से छोटा हो सके उतना छोटा छोटा, आर जितना बड़े से बड़ा हो सके उतने से बड़े से बड़ा, उस बिकॉज वी हैव टू इंटीग्रेट इट फ्रॉम जीरो टू इन्फिनिटी। एप्सिलॉन जीरो की तरफ क्यों टेंड कर रहे हैं? बिकॉज we have the problem with zero, we don't have problem with other points, so we are making a very small circle around x, z equal to zero। और क्योंकि z equal to zero पे ब्रांच पॉइंट है, सो आई हैव मेड अ ब्रांच कट। सो ये ब्रांच कट मैंने बनाया along द पॉजिटिव एक्स एक्सिस, बिकॉज मैं एंगल यूज कर रहा हूँ फ्रॉम जीरो टू पाई। Okay, so I'm on my principal branch right now. Is that clear?
सर आर टेन टू इन्फिनिटी तो माइनस इंटू टू इन्फिनिटी रीजन कवर करेगा ना,
मैं नहीं समझा, आर
क्योंकि हमारा
टेंशन।
कॉन्टूर, क्योंकि कॉन्टूर सर लेफ्ट हैंड साइड में भी एक्सपैंड करेगा और राइट हैंड साइड में भी एक्सपैंड करेगा अगर आर टेन टू इन्फिनिटी लेगा तो।
ओके, सो अंडरस्टैंड, आर मतलब रेडियल कोऑर्डिनेट है। ओके, सो रेडियल कोऑर्डिनेट का मतलब ये होता है कि रेडियल कोऑर्डिनेट इज टेकन फ्रॉम द ओरिजिन। सो ऐसा कुछ समझो। सो रेडियल कोऑर्डिनेट कभी भी नेगेटिव नहीं होंगे, इट विल ऑलवेज रिमेन पॉजिटिव।
हाँ जी सर, इट विल ऑलवेज रिमेन पॉजिटिव, दैट्स व्हाई इट विल कवर एंटायर रीजन नो।
हाँ
मतलब
इट
जो
विल।
हमारी इंटीग्रल की लिमिट है जीरो टू इन्फिनिटी, वो माइनस इंटू इन्फिनिटी है एक्चुअली में।
हाँ, बट आई एम नॉट गेटिंग, उससे मिलेगा मतलब, व्हाई आर यू गेटिंग कंफ्यूज्ड देयर? आई एम नॉट गेटिंग। मतलब हाँ, पूरा रीजन वुड कवर्ड, आई मीन हाउ शुड आई से, मतलब दिस एंटायर थिंग वुड बी कवर्ड एज लार्ज एज पॉसिबल। हाउ शुड आई से, ऐसा कुछ, ये जो दिख रहा है, this can expand as large as, this is your region where we are integrating, right? This is your sort of region where we are, समझ पा रहे हो? ये मतलब आर बड़े से बड़ा हो सकता है, जितना बड़े से बड़ा चाहे, सो दैट हमारा इंटीग्रेशन जीरो से इन्फिनिट मिल जाए हमको, राइट? मतलब हमें क्या करना है, जीरो से इन्फिनिट एक्स की पावर पी अपॉन वन प्लस एक्स को तो इंटीग्रेट करना है। सो हमने क्या किया, हमने उसके बजाय प्रॉब्लम ले ली जेड की पावर पी अपॉन वन प्लस जेड। अब एज आर टेंस इन्फिनिट तो पूरा रीजन कवर हो जाएगा, मतलब जितना बड़े से बड़ा चाहना चाहे। इन योर लैंग्वेज, यस, हाँ, मतलब from negative to positive everywhere. Okay, is that clear?
Yes,
समझ
sir.
पा रहे हो मेरी बात? And understand this minus 1 lies inside. So this is your closed curve. समझ पा रहे हो? इस पूरे रीजन के अंदर टक 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 इसके अंदर कहीं ना कहीं -1 बैठा हुआ है. सो ये जो लेफ्ट हैंड साइड वाला इंटीग्रेशन वो कितना हो जाएगा? 2 पाई आयोटा इंटू रेसिड्यू. रेसिड्यू कितना हो जाएगा? लिमिट z टेंस टू -1 z की पावर p -1 अपॉन z प्लस 1 इंटू z प्लस 1. सिंपल पोली तो है. So this gets cancelled. Overall, it will come as -1 की power p -1. Is that clear? Into 2 pi iota. So your left hand side is this. Is that clear?
सर p को 0 to 1 में रेस्ट्रिक्ट करने का क्या मतलब है?
वो मतलब मैंने नहीं रिस्ट्रिक्ट किया, क्वेश्चन में गिवन है. ठीक है. So this is your question. So that I cannot do anything about it. So this is where we are starting from. Okay. So in
मतलब
this
p could have
integration,
any value, sir.
हाँ, अगर एनी वैल्यू हो जाती तब फिर आप इसको मल्टी वैल्यूड नहीं कहते ना. लेट्स से p इज ग्रेटर देन 1, देन आई डोंट हैव अ प्रॉब्लम. I have a problem for p lies between 0 and 1. So for example, अगर p 2 हो जाए तो कहाँ प्रॉब्लम है? x equal to -1 ही तो है. तो फिर इतना सब नाटक करने की जरूरत ही कहाँ है?
ओके ओके, फिर वो ओके ओके सर, ब्रांच पॉइंट नहीं है. ओके.
ओके. सो अब हम थोड़ा ध्यान से देखते हैं एक एक इंटीग्रेशन को उठा के, लेकिन टाइम अपने पास कम है तो थोड़ा थोड़ा सा जल्दी करेंगे. ठीक है. सो राइट हैंड साइड लेफ्ट हैंड साइड आई हैव ऑलरेडी रिटन -1 की पावर p -1 into 2 pi iota. Keep an eye over here and keep an eye as to what I'm doing. Okay. So now first take integration hja. पहले इसको देखते हैं. So what is integration hja? इंटीग्रेशन अलोंग hja. तो देखो ये छोटा सा सर्कल बना हुआ है, इसको भूल जाओ. ओवरऑल दिस इज अ सर्कल हुज रेडियस इज एप्सिलॉन. बात समझ में आई?
यस सर.
whose radius is epsilon, and I'm going about from 0 to 2 pi. So, and also this integration is in the clockwise direction. Is that clear? So I'll write clockwise here. कल की तरह नहीं तो कंफ्यूज होंगे तो clockwise here, and this integration को मैं ऐसा लिखता हूँ. कहाँ गया z? z ये रहा. So z की जगह क्या आ जाएगा? Any point on this particular can be written as epsilon e की power iota theta. So this will be epsilon e की power iota theta raised to power p minus 1 upon 1 plus epsilon e की power iota theta. Is that clear?
यस.
Z की power p और then iota epsilon e की power iota theta d theta. In the limit epsilon tends to 0. और ये चीज कहां से कहां तक जाएगी? 0 से लेकर 2 पाई तक लिख दी मैंने, और यहाँ क्लॉकवाइज पहले लिख दिया. तो जो भी आंसर आएगा उसको नेगेटिव से मल्टीप्लाई करना. इज दैट क्लियर? This
राइट.
integration would be equals to iota, and there are terms. I'll write it. This is epsilon की power 1. This epsilon की power p minus 1. So this is epsilon की power p minus 1 here. Okay. Upon 1 plus epsilon e की power theta, and then you have epsilon e 1 plus epsilon e की power iota theta, and then you have e की power iota p theta d theta. Is that clear? Is that clear to you? ये चीज समझ में आ रही? फटाफट बोलो, we don't have time.
सर
Otherwise this
एप्सिलॉन की पावर p.
एप्सिलॉन p होगा.
epsilon p.
p होगा एप्सिलॉन.
Sorry, epsilon की power p. Is that clear?
यस.
अब देखो जो भी है, whatever it remains, I'm not worried also. You just think that this entire thing depends upon what? This entire thing depends on theta. And now I'm taking epsilon tends to 0. So it does not depend on epsilon right now. Isn't it? Isn't it? It does not depend on epsilon. So I can take epsilon outside. So whatever this integral is, I'm not bothered, but epsilon raised to power p is outside. And as epsilon tends to 0, this entire thing will become 0. Is that clear? Or you can take the
Yes,
same
sir.
thing, you can take a modulus, then you can write. This will become a very long exercise for you right now. But understand this integral would become 0 as epsilon tends to 0. Because p is positive, epsilon is here, so it will tend to 0. Is that clear? फटाफट बोलो, yes or no?
Yes, sir. Yes, sir.
नहीं तो ये
Yes,
this
yes.
lecture will turn
हाँ
down,
हाँ.
and फिर I'll have to take another lecture which you will not be willing to. So that is what I'm doing. So this
No,
integration
we
now
are willing.
you are willing, but somewhat अभी कचरा होने वाला है. So this is another integration is b d e f g, and this I'm taking as r tends to infinity. This I'm doing as r tends to infinity. Is that clear? So any point on that is r e की power iota theta p minus 1 iota r e की power iota theta d theta upon 1 plus r e की power iota theta. Is that clear? इसमें कुछ गलती तो नहीं कर रहा हूँ? फटाफट चेक करो. So this will give me integration from 0 to 2 pi. This is called clockwise only, so I'm not bothered about it much. R tends to infinite, and this will give me, I think, iota is there. So this will give me e की power iota p theta d theta. Then you have r की power p here, and then you have 1 plus r e की power iota theta. Is that clear? यही होगा ना मेरे हिसाब से, है ना? Take a modulus. Take a modulus. So this modulus will be less than equal to modulus inside, है ना? And understand e की power iota p theta का modulus will be 1, so I'm not bothered about it. So what I will get is r की power p upon 1 plus r की power iota theta का modulus. And d theta का modulus integration from 0 to 2 pi. Is that clear? अब थोड़ा सोचते हैं
Yes.
कि देखो z1 plus z2 का जो mod है, it will always be less than equal to z1 का mod plus z2 का mod, but it will not give you anything right now. Okay, so what you can do is you can just see here, भूल जाओ इसको, just see in the denominator end, just see on the denominator, or you can write z1 plus z2 का जो mod है, it is always greater than equal to mod of z1 minus mod of z2. Is that clear? So 1 plus r e की पावर iota theta का जो मॉडुलस है, it will be less than equal to 1 upon 1 minus r, because e की पावर iota theta का mod हो जाएगा 1. So this will be less than equal to r की पावर p upon 1 minus of r, and d theta integration is simply 2 pi. अब सोचो, as r tends to infinite, this is r की पावर p, so p lies between 0 and 1, and this is r की पावर 1, so denominator की पावर ज्यादा है, so r tends to infinite पे 1 को तो भूल ही सकते हो, क्या फर्क पड़ रहा है? So you have this only r remaining here, so r tends to infinite पे ओवरऑल टर्म कहाँ जाएगा? 0 पे नहीं जाएगा. सोचो, ये r की पावर p है, p किसके बीच में था?
Yes,
0
sir.
से लेकर 1 के बीच में, नीचे r की पावर 1 है, टेंस टू इनफिनिट पे जाएगा 0. So overall you will find that these two integrations are 0. Is that clear? These two
Yes, sir.
integrations are 0. These two integrations are 0. In the limit, epsilon tends to 0 and r tends to 0. Up, this entire integration is equals to what? This entire integration is equals to, I will write here, is equals to minus 1 की power p minus 1 into 2 pi iota is equal to integration, I think 0 to infinite x की power p minus 1 upon 1 plus x dx, because along AB, whether you write z or whether you write x, they mean one and the same thing. Along GH, what has changed? So if I move along GH, so I will have to take another 15 minutes of this. Take say 15 minutes because the class is almost about to end. So I'm just going to write plus integration along GH and just 15 minutes, not more than that. Okay, so 1 plus z dz. Okay, now if I move along GH, if I move along GH, what will be the coordinates like? So I'm moving along GH, what will be the coordinates like? Understand my point? When I was moving along this direction, your angle was 0. When I'm moving in this direction, what would be the angle? This is my question. So for example, you just see this particular contour and give me an
Why?
answer in the next session, okay? Because it is about to end. Okay? So just think about it and tell me an answer. So it would hardly take a minute from here.